Okay, we didn't really go over this type of problem, but I find it interesting, so I'm going to show you how to do it. So if you want to express this repeating decimal as a rational number, the trick is if you let that number equal x, then that means 100x, or 100 times this number, would move the decimal place over twice, giving you 45.45, 45, 45, and so on. Then what you do is you do minus x. So 100x minus x would actually give you minus 0.454545, and so on. Because you see how this minus x, if x is positive this, and minus x is minus that. So doing a little bit of the math, if I take 100x minus x, you get 99x. Then 45 point all this minus point all this cancels out all the decimals, and I have just 45. Last step would be to divide by 99, so x equals 45 over 99. In case you don't believe me, there it is. Now this is also the way that you solve and find what 0.999999 repeating equals. If you let x equal that, then all you have to do is multiply by 10x, and then the 10 would move the decimal place over 1, so you have 9.9999, and so on. Subtract x makes you subtract 0.9 and all the decimals after it. 10x minus x gives you 9x. 9.999 minus 0.999, all the 0.999s cancel out. So then all you're left with is 9 on the right side. Divide by 9, and you get x equals 1. So that's exactly why 0.999999 repeating equals 1. To determine whether a series is convergent means you're trying to find out whether the sum of your terms will ever stop eventually. So basically, if you keep adding the next term, eventually that sum, all those numbers, are going to add up to a finite number. It means it's going to be some number you can count to. It's not just going to get bigger and bigger and add forever. So basically what you do is you got to figure out the pattern, see what the sum would be, and see if it would converge or diverge. The one thing you definitely need to know about convergent is the terms need to get smaller. Definitely need to get smaller. That's one of the key things. Meaning if it doesn't get smaller, meaning the terms get bigger, you automatically know that this is going to diverge, meaning it's just going to get bigger and bigger and bigger, either in the positive or the negative direction. It'll never stop. It'll just get larger and diverge. So one of these is obviously getting larger, getting bigger, meaning it's going to... If I look at the first one, first term is 1/4, and it goes to 1 to 5 over 16, 3 over 8, 7 over 16. Just looking 1/4 and 3/8, you can see that these terms are getting bigger. This is increasing. The next term you add is getting is bigger than the previous term. So this is easily going to diverge. pretty easy to see that. A and B, on the other hand, you can tell pretty easily that 1/9, 1/27, 1/81st, these are definitely getting smaller. Same with B, 1, 1/5, 1/25. And not only that, the ratios are pretty easy to see. On this, all you're multiplying by each time is 1/3, because on the bottom you just multiply by 3. 9 times 3 is 27, times 3 is 81, and so on. It even gives you this thing right here. This is giving us a ratio basically. So here the ratio would be 1/5. The n plus 1 and the n minus 1, that just helps you shift either starting at 1 or starting at 1/9, depending on where you want to start in this sequence. To be more specific, to see what this number actually converges to, it's good to have this handy. We know R. We can easily find the first term and use this sum. And this is going to be for a partial sum because you're going to stop at n. That means you have the first n terms. But notice this ... means that it's going to go on forever. And so that means you need to use this formula. Since R is less than 1. Notice we said R is 1/3 here, R is 1/5 here. That falls into this category between -1 and 1. If R is greater than 1 or less than -1, then that diverges. As we said, that means it's getting bigger. R greater than 1 would mean that it's getting bigger. So if I want to find, let's say for part A, I need to use S for the infinite sum. It's going to equal A1 over 1 minus R. The bottom's easy, 1 minus 1/3. A1, how do I find A1? All I have to do is look at the very first term, 1/9. So, doing a little bit of simplification, 1/9 on top. 1 minus 1/3 is 2/3. And like I said before, the numerator, bring that up and take the reciprocal, 3/2, multiply across. The 3's cancel out some. 1 here, 3 down here. So I end up getting 1 times 1 over 3 times 2, 1/6. If I add up all of these different numbers, you're going to only get 1/6. Looking at the next one, part B, I still want to use S equals A1 over 1 minus R. Again, the bottom is easy, 1 minus 1/5. On the top, A1 is just going to be 1. That's pretty easy, 1 divided by 4/5. If I have 1, take away 1/5, you get 4. And then, instead of having the 4/5 down here, I'm going to bring that up and have a 5/4. Since I'm multiplying by just 1, you don't really need to do much fancy math. It's just 5/4. And that's what the number will converge to.